Hello, everybody, and welcome back to the podcast. Today's episode is titled The Chemistry of Coffee, What's Actually Brewing? Now, if you're anything like me, your day didn't start officially until you had your first cup of coffee. We love the smell. We love the caffeine kick. Have you ever stopped to think about the fact that your morning brew is just a complex chemical extraction? Today, we're going behind the barista counter and into the lab to look at the molecules that make coffee. Let's brew it. At its core, brewing coffee is a masterclass in solid liquid extraction. You're using a solvent, hot water, to pull soluble compounds out of a solid matrix, the roasted and coffee ground beans. But here's the catch. Not all compounds extract at the same rate. It's a game of molecular weight and polarity. First up, you have the fruit acids and organic compounds, things like citric acid and malic acid, which dissolve almost instantly. If you under-extract your coffee by rushing the brew, this is all you get, which is why under-extracted coffee tastes sour. Next up is the good stuff. Lipids, oils, and our favorite stimulant, caffeine, are extracted next, balancing out that acidity with body and sweetness. Finally, you get the heavy hitters, chlorogenic acid lactones and phenylenedines. These extract last, and they're intensely bitter. If you leave your water running too long and you over-extract, leaving you with a cup that tastes like liquid charcoal. So a perfect brew is literally just stopping a chemical reaction at the exact right thermodynamic sweet spot. But the chemistry starts way before the water hits the mug. It starts in the roaster. Green coffee beans don't smell like coffee at all. They smell like grass or peas. To get that rich, heavenly aroma, we rely on one of the most famous chemical events in the food science, the Maillard reaction. When the beans hit temperature around 140 degrees Celsius, reducing sugars react with amino acids. This creates a cascade of hundreds of new flavors and aroma compounds. Basically, roasting is controlled chemical destruction, transforming raw plant matter into complex cocktails of volatiles. We can't talk about coffee without talking about caffeine. But how does it actually keep us awake? It's all about molecular mimicry. Throughout the day, your brain builds up a neurotransmitter called adenosine. Adenosine binds to specific receptors in your brain, slowing down nerve cell activity and making you feel drowsy. It's your body's natural time-to-sleep signal. Enter caffeine. If you look at the chemical structure side by side, caffeine looks remarkably like adenosine. It's a molecular imposter. Caffeine fits perfectly into those adenosine receptors, blocking them. Because caffeine is occupying the parking spots, the real adenosine can't talk. Your brain never gets a slow down signal. Your neurotransmitters keep firing, and boom, you feel wide awake. So the next time you pour yourself a cup, take a second to appreciate the physics of extraction, the organic chemistry of the roast, and the biochemistry happening in your brain with every single sip. You're not just drinking a beverage, you're drinking a science experiment. That's all for today's episode. If you like parsing out the chemistry of your morning routine, hit that subscribe button, leave a comment letting us know how you brew your coffee, and share this with your favorite caffeine addict. Until next time, keep experimenting and have a great day.